Alright, this is the last section in this unit. And today we're talking about special right triangles. So there are two types of special right triangles. The first one is a 45, 45, 90. And we call them by their angle names. So on the inside, notice there's it's a special right triangle, so one of them has to be 90. And the other two are exactly the same at 45 and 45. Now, if you have angles that are the same measure, the sides opposite are also going to be the same. So since 45 and 45 are both congruent, we know the sides opposite them, this leg and that leg, are also going to be congruent. So this is A and that is A. When this happens, there's a special relationship, and we just always know that this hypotenuse is going to be the length of the leg times the square root of 2. Now, why does that work? It's because of the Pythagorean theorem. For instance, if A is equal to 1, and I want to find out what is C, we would have 1 squared plus 1 squared, and we're looking for C squared. That's 1 plus 1. That's 2. Square root both sides. The square root of 2 is equal to the hypotenuse, which means that it's 1 times the square root of 2. So whatever the leg is, you take it, multiply it by square root of 2, and that gives you the length of the hypotenuse. Only for 45, 45, 90 triangles. Now if they give you the hypotenuse and you're going backwards for the leg, you simply divide by the square root of 2. So this, you don't have to worry about knowing that little piece of it. That was just so I could kind of prove to you that it works. Here's your first example. So if I have a 45, 45, 90, I'm not going to draw it very big. And I tell you the leg is 3. Each of the legs are 3. I want to know what the hypotenuse is. Now, you could do 3 squared plus 3 squared is equal to C squared. Add them up, take the square root and do it that way. Or we could just say, I know the relationship between a 45, 45, 90 says the leg times the square root of 2 gives me C. So the hypotenuse, C, is equal to the leg times the square root of 2. So you could just leave that as 3 square root of 2. If you wanted to multiply that out, .2. And that's all that's to it. It is that simple. Now the other one is a little more complex, but not too bad. And it's what we call a 30, 60, 90. So in this one, we have 30 degrees in one of them, 90 degrees in the other, and 60 degrees in this one. Now this relationship is a little bit different. You have to be a little more particular about which ones go where. The 30 degrees indicates the side opposite is the shortest side. So we're just going to label it with our base value of A, whatever the variable is, x, A, whatever. It's your base length. To get to the hypotenuse, you multiply it by 2. So this hypotenuse would be worth 2 times A. To get to the other leg, across from 60 degrees, you simply say A times the square root of 3. So instead of doing 2 like we did for the 45, 45, 90, it's times the square root of 3. And so these are our proportions. So you always take the base, which is the opposite of that 30, multiply by the square root of 3 to get to this one, multiply by 2 to get to this one. So let's do a quick example of this one, and then we'll do more practice of this one in class. So if I give you a triangle, if 30 degrees is here, 60 degrees is here, this is y, this is z, this is 4 centimeters. 30, 60, 90. The one opposite the 30 is your base, that's your smallest. So how do I go from the smallest to the hypotenuse? Z is simply going to be 2 times this length, which is 4, so that's going to be 8 centimeters. Y is going to be 4 times the square root of 3, which you could just leave as 4 square root of 3, or we could multiply it out and get 6.9 centimeters. Again, not hard, it's just being sure to carefully identify which one's the shortest and what you're multiplying it by for each particular side. So again, we'll do more practice with this inside of class, but this is the basis for these two special right triangles, one that's 45, 45, 90, and one that's 30, 60, 90.